Hey guys, welcome to math tutorial number 2. In this tutorial, we'll be looking at methods of solving limits. So we're given this limit as x approaches 5 and the function is x squared plus 2x minus 4. But the first thing we want to do when we see limits is substitute this value into the function itself. So let's do that and let's see if we get the answer. So if we directly substitute 5 where we see x in the function, it's going to become 5 squared plus 2 times 5 minus 4. 5 squared is 25 plus 2 5s is 10 minus 4. This then becomes 35 minus 4, which would then become 31. That would be our solution. This method is called direct substitution, as the only thing that we did was substitute this value into the function and we got a answer. So for this second example, we're given the limit as x approaches 2 of a fraction. So when you see limits that have fractions, the first thing you want to do is take out this denominator, drag it one side, and if I do that, we're going to have x minus 2. If we substitute 2 into this, we get 0. If your denominator is 0, that limit does not exist. And we know we have to do something else to get the solution. So seeing as we got 0 for denominator, what do we do? So we look in our numerator and we realize both of these terms can be factored. So let's factor the numerator. So we're going to write limit as x approaches 2. I'm going to factor out this numerator. Now we have terms that can cancel. We have this x minus 2 and the x minus 2 in the denominator. So now this turns into the limit as x approaches 2 of x plus 2. And now we can directly substitute. That would turn into 2 plus 2, which would give us 4, which is our answer. And this is our factoring method. So now we have this third example. And in this third example, we're realizing something new. So the squared, we're seeing cube. And similarly, we have a fraction. So we know what we do first. We take out this denominator. We directly substitute. See what we get. We get 0. So we know we have to do something. Now we have a cube. And from we say a cube, we know we have to use the difference of cubes rule. So this here is our difference of cube rule. It's essentially a formula that you implement over on the left side over there to solve any limit that has a cube. But before we can substitute in these values, we have to find out what a and b are. So let's assume this part of the term as our numerator. So we can see that x cubed is a cube. We can see that b cubed is 27. So let's write that. A cubed is equal to x cubed and b cubed is equal to 27. Now if we want to get a and b, we can do simple algebra and get a equals x and b equals 3, because 3 cubed is 27. Now let's actually solve this limit. So we write back limit as x approaches 3, and for numerator we're going to write in this segment. So a minus b, a squared plus ab plus b squared. We just write back our denominator as is. And then we'll go limit as x approaches 3. Now we substitute in our values that we solved with algebra. So it's x minus 3 x squared plus, okay, put 3x plus 3 squared x minus 3. And again, we see some terms that we can cancel out. Let's limit as x approaches 3. We no longer have a fraction, so now it's just x squared plus 3x plus 3 squared. And we can directly substitute, huh? So that becomes 3 squared plus 3 times 3 plus 3 squared, which is equal to 9 plus 9 plus 9, which gives us 27, which is our answer. And again, this is the difference of cubes rule. Okay, now we have another example. This one looks very different from all the ones we've done so far. And we're seeing fractions within the bigger fraction. And this one is going to be called a complex fraction, or the complex fraction method. So how do we go about solving this? Well, any limit that you see, take out the denominator and substitute in the value to see what you get. We get 0. We have to use another method to solve this. So we see this numerator, and this numerator is looking quite complex. It's a fraction within a larger fraction, and we really want to get rid of it. We're going to multiply by the common denominator of those fractions. Remember from our earlier math times that we know if you have x and a number, it's just the number times x. And whatever we do for the numerator, we have to do for the denominator. So let's rewrite this. It now becomes the limit as x approaches 3 of, let's write back the fraction line, right in our denominator, put in brackets 3x. For numerator, it's 1 over x minus 1 over 3. Now we're supposed to multiply our fractions in the numerator by our 3x. So limit as x approaches 3. We're going to leave the denominator as is. I like to do that, as you might find later on that you have some terms you can cancel. And our numerator is going to work out to be 3 minus x. Now this looks familiar because we have two terms that are similar. The only difference is the signs are different. We know how we can change that. We can just factor out -1. So we go with the limit as x approaches 3, -1. And I'm going to rewrite this as x minus 3 all over 3x x minus 3. And we see what we can cancel out here. So let's bring this over. This then becomes the limit as x approaches 3 of -1 over 3x. And we can direct substitute from here. So equal -1 over 3 times 3. 3 times 3 is 9, so that becomes -1 over 9. That's our answer. And again, this is called the complex fractions method. And you use this to solve any limit that has a fraction within the fraction. Now let's look at our final example. We're seeing something new again. This example has a square root. We know in math, how do you get rid of a square root? You multiply by by square. But you can also work some magic with factors. When you work out those factors, you're going to get a number minus another number, which would also get rid of our square root. Substitute, see what we get 0. So we know we have to use a different method. So let's use it. Conjugate method is you multiply by the term that has the square root, and you change the sign of the other terms within that term. Sounds a bit confusing when I say it like that. So this will just turn into root x plus 3. Now we know whatever we do to the numerator, we have to do to the denominator. It's root x plus 3. So let's write that on a line below in a more controlled manner. So root x minus 3, root x plus 3. Our denominator is x minus 9, and then root x plus 3. So we have this new limit function, and we say, okay, what can we do from here? Well, let's leave this denominator alone. So let's write it back, and let's work out this numerator. Let's work out the factor. So we have limit as x approaches 9, and that factor would turn into x plus 3 root x minus 3 root x minus 9 all over. So we said we're leaving our denominator as is, root x plus 3. And as I said earlier, we can get rid of square roots by getting terms that will subtract. In this case, we have these two terms which cancel each other out. So that leaves us with limit as x approaches 9 of x minus 9 over x minus 9 root x plus 3. And we see some more terms that can cancel. Let's bring this up here. This is now the limit as x approaches 9 of 1 over root x plus 3. And if we can directly substitute now, so that becomes 1 over root 9 plus 3. Root of 9 is 3, so that's 1 over 3 plus 3, which is 1 over 6. And that is our answer using the conjugate method. And that wraps up all the basic methods of solving limits.